Today we're going to learn a little bit about projectile motion. In the next video, I will solve a sample problem for you. Okay, projectile motion. It's a form of two-dimensional motion. Specifically, we're going to deal with stuff that's moving on Earth underneath Earth's gravitational pull. It's going to be traveling horizontally and vertically at the same time. Here I have a drawing of an object shot off of a cliff, following a parabolic trajectory, landing eventually on the ground. Some key features of a problem like this. We have a height of the cliff, a horizontal distance of travel of the object, which sometimes this is called range of the object. How far downrange does the object travel? Some other stuff that we have. We have here time to impact. We also have a certain velocity at impact. Okay, a few key features about the way the object travels here. This object leaves the cliff. It's going to be traveling initially with only horizontal velocity. And its vertical velocity is going to be 0 meters per second. A few moments later, after that object has had a little time to travel, Earth's gravitational acceleration force has had a chance to accelerate the object. So now it's got a little bit of vertical velocity. The horizontal velocity, however, is going to remain constant. There's nothing accelerating the object horizontally. So Vx initially is the same as Vx a few moments later. This object, let's go through a few more iterations. It's going to fall a little further. Continue accelerating downward. Maintain a constant horizontal acceleration. Even further, the vertical velocity continues increasing. The horizontal is constant. So, something I've been trying to show here. Horizontal velocity remains constant because nothing is accelerating it. The vertical velocity increases downward according to the acceleration of Earth's gravity. When you solve these problems, remember that horizontal motion and vertical motion don't interfere with each other. So the fact that this guy is accelerating in the y does not at all affect the displacement of the object in the x. Some relevant calculations you might need here. Knowing that the horizontal velocity is constant leads you to the definition of constant velocity. There you go. Knowing that the y velocity increases, any of the kinematics equations for accelerated motion apply. One that's particularly relevant, I'm going to change the x's in that equation to y's. The change in the vertical position of this object is equal to its initial velocity in the y direction times time plus a half at squared. The initial velocity in the y direction, as I laid it out here, is 0. The object's only moving horizontally. That makes that whole term disappear. It means that more often you're using this equation. Okay, projectile motion in a nutshell. Check out the next video for how to solve a projectile motion problem.